Good morning, good afternoon, good evening. It's your boy Mr. Malachi, and welcome to this video where we're going to be unpacking analytical geometry. So what is analytical geometry? Analytical geometry is the geometry of shapes, lines, and how that translate to algebraic expressions or algebraic equations. So that is literally what analytical geometry is. It takes something that we can put on a coordinate system, like a triangle like this, and then it tries to represent the triangle in terms of algebraic equations, right? So it could be algebraic equations where we are actually calculating the area of that triangle or the perimeter of that triangle, or it could be trying to find the equation of this line AB. So that is literally what it is. And today we're going to be unpacking these three formulas. The first is the gradient formula. So what does gradient stand for? Gradient stands for the slope of a line, how steep or how shallow or how flat that line is. So that is what gradient is, and it's calculated by y2 minus y1 divided by x2 minus x1. I'll tell you more about what those things mean. Then we have the second formula that we need to be familiar with, which is the distance formula. And that one says the square root of x2 minus x1 squared plus y2 minus y1 squared. And if you square root that whole thing, you will get the distance between 2 points. Then lastly, midpoint. Midpoint tries and finds what is the middle value of two coordinates. For example, I have this coordinate A up there, I have this coordinate B down there. So what I'm interested with the midpoint is I'm interested in what is that middle value that would sit somewhere there, right? Again, distance measures or rather calculates how far A and B are from each other, or the length between A and B. And gradient again measures how steep that line A and B is. So yeah, that is the general idea there. Let's jump right into it and calculate these magnitudes for each of these. So let's just push it this side. So let's first calculate gradient. Gradient is written as m y2 minus y1 over x2 minus x1. So what does that actually mean? You need your coordinates first of all, which you're given the a, which is 1 and 3. We're given the b, which is a negative 3 and a negative 2. So remember, coordinates are written as an x and a y. They always come like that, the x first and then the y. So how do you actually substitute and calculate that? One thing you need to do is label them 1 and 2. It doesn't matter how you label them. I'm gonna call the A number 1 and I'm gonna call the B number 2. So if it says y of 2, I go to the 2 and I'm looking for the y coordinate. Remember, y is always the second coordinate. So that's the value I'm going to be substituting for y of 2. That is going to be subtracting this y of 1, which is a 3. This is all divided by x of the 2, which is the negative 3. That is subtracting a positive 1. And if you plug that into your calculator, you should get a negative 5 over a negative 4, which is just simply a 5 over 4. Simplify. And there we go. That is how steep this line is, the slope of that line. So we've calculated gradient. Now let's go on and actually calculate the distance of these points. So let me just erase this. So to calculate distance, I'm going to need the distance formula. You can write AB. AB stands for the distance of AB. There is my distance formula. You always need to write it every single time when you're solving these type of questions. So now that I have my distance formula, I substitute again. It's already labeled as number 1 and number 2. So let me substitute them correctly. So my x of 2 is going to be this negative 3 there. So a negative 3 is being subtracted by a positive 1 squared, plus my y of 2 is this negative 2 that is subtracting the 3 at the top. And if you plug that whole thing into your calculator, let's plug it in, let's see what we're getting. And the value that you should be getting is the square root of 41. If you want to leave it like that, you could leave it like that. Or if your examiner wants it in 2 decimal places, then that distance would actually be 6.40 units. So this is a distance. You do need to indicate the units there of that distance. All right, so now we've solved for distance. That's how you solve for distance. Then now let's look at how do we solve for the middle or the midpoint of AB. So midpoint is separated because midpoint is going to have an x of m, a coordinate, and a y of m, a coordinate. Again, just like how we have x and y, this is the x coordinate of the midpoint, and this is the y coordinate of the midpoint. So how do we calculate the x coordinate of the midpoint? X coordinate of the midpoint is y2 or x2 plus x of 1 divided by 2. Again, these are labeled. I just need to substitute them correctly. So the x of 2 will be the negative 3. That is adding the positive 1 divided by 2. And thus we end up getting a negative 1. So let's calculate the ym, or the y coordinate of the midpoint. Again, you use your formula. And if you substitute this, y of 2 is this negative 2 that is adding a 3, all divided by 2. And if you plug this into your calculator, you'll get a positive 1.5. So what does this actually mean? It means this value right there, the midpoint of that guy sits right there, where m is a negative 1 for the x and a half for the y. And there we go. Even pictorially, it does make sense that it's right there at negative 1, but it corresponds with a half value of y. And there we go. Very easy. That's how you solve for gradient, and that's how you would solve for midpoint, and that's how you'd solve for distance. Let's look at one more example. Alrighty, so let's look at this example. Again, we're given A and B, and what the question is asking us is, question A, calculate gradient. Question B, calculate distance. And question C, calculate the midpoint. So this time the picture is not given, but we don't really need the picture to actually do these questions. So number one, gradient is always y2 minus y1 over x2 minus x1. The m is just the variable that's given for gradient. So again, you need to label these. So I'm going to label this number 1, and I'm going to label this number 2. Then if I substitute, it will therefore be y of 2, which will be this 5, that is subtracting the 2, which is this 2 there, divided by this 1, that is subtracting, but you're subtracting a negative 1. So you have to make sure you put that negative 1 in brackets. And if you plug that quickly into your calculator, you'll get a 3 over 2. So that is the gradient of that guy. That is A. Then to calculate the distance of that, the distance of AB is x of 2 minus x of 1 squared. That's the formula. Y of 2 minus y of 1 squared. And if again I just substitute there because it's already labeled up there, the x of the 2 will be the 1 that is subtracting a negative 1. Again, be careful if you're subtracting something that is already a negative. And then this one will just be 5 that is subtracting a 2, and you square that, and if you plug this into your calculator, it gives you that the distance of AB is actually the square root of 13. And yeah, I will just leave it like that for now. But if your examiner wants it in surd form or in decimal form, you would just plug that guy in, press SD to get the decimal form. To calculate midpoint, x of m is equal to x of 2 plus x of 1 divided by 2. Another thing that I did not mention when I did the previous question, I did show the final coordinates of the midpoint. All right, so let's keep doing these. Let's substitute. So x of 2 is the 1 that is adding the negative 1. Again, be careful. And if you plug this into your calculator, it actually gives you 0. So that's the x coordinate of the midpoint. To find the y coordinate of the midpoint, y of 2 plus y of 1 divided by 2. Y of the 2 is the 5 that is adding the 2, and you're dividing by 2. And what does this give you? This one gives you a 7 over 2. All right, and so what does that mean? It means therefore the coordinates of the midpoint is a 0 and a 7 over 2. And there we go. Very easy. I hope you guys are seeing how this is happening. Again, you just need to know your formula, substitute into your formula, and get your answer. Obviously, before you substitute, you kind of do need to label these guys so that you have which one is 1, which one is 2, so that when you substitute, you keep that consistency, because that consistency is very important. So let's look at one more question about midpoint, and particularly this one. It's quite nice because instead of trying to find the midpoint, we are instead given the midpoint and one of the other values, and we have to find what is the end point. So let's look at that example. All right, so in this question here, this is a very nice question. What we are told is that we have a line, right? I'm not going to draw it on the Cartesian plane, but I'm going to just draw it here quickly, just so we have a picture of what's happening. So this line is called the DB line, right? And right there in the middle is where our A is. So we're not given the coordinates of D, we're given as just X and Y. We're not given the values of those, obviously. We're given the coordinates of A, and we're given the coordinates of B. And what we need to do is we need to use our midpoint formula to actually find this guy, which is our end value, if you want to think of it like that, or you can think about it as your start value. So how do we go about that? You again use your midpoint formula, which says x of the midpoint is equal to x of coordinate 2 plus x of coordinate 1 divided by 2. And what we're going to do now is that we're going to actually substitute this x coordinate of the midpoint because it's given. So this negative 1 here, we're going to substitute for the x of the midpoint because it tells us that A is the midpoint. So we're going to substitute it that side. And if I label these guys, I label this number 1 and I label this number 2. So the guy that I don't have is the x of 1. But I have the x of 2, which is this one here. So it will be a 1 plus an x. X of 1 I don't know, so I put an x there. And I divide this by 2. And how you go about solving that is you always times by 2 on both sides, because there's always going to be the 2 that is dividing. So if you times by 2 on both sides, these cancel. This gives you a negative 2, 1 plus x. And if you take that over, x is actually equal to a negative 2 minus a 1, and x is a negative 3. I hope you guys can see that. Then another thing that we need to solve for is the y coordinate. So the y midpoint formula looks like that. And now since we've labeled, we just need to be sure that this guy here, the y coordinate of that A goes for the y coordinate of the midpoint, this ym part. And we don't have y2, or we have y2, which is the 5. We don't have y1. We're just going to put it as a y there. And how do we solve this? You times by 2 on both sides. So we get a 4. These 2's cancel. And if you take your 5 to the other side, a 4 minus a 5 will tell you that y is actually equal to a negative 1. So what does this mean? Therefore, the coordinates of D are a negative 3 with a negative 1. And I hope you can see that. Again, this is very useful. This is something examiners, especially at grade 10 level, they like asking this type of question in your tests and exams. So make sure you know how to do it. And on that note, that's it from my side. Check out the next video where we're going to be talking about how do we find the equations of these lines, and further on, how do we go about drawing these lines when we're given the equation. That's it from my side. I'll see you in the next video. Bye.